Now that you've collected the necessary data, you will add it to a blank QGIS map document. So open QGIS Desktop and then use the Add Vector Layer button and add all 4 shapefiles to QGIS Desktop. So select File, Browse, go to your Lab 7 folder, go to Raw Data if you didn't download the data yourself, or My Data if you downloaded the data. Select them all and click Open, and then Open one more time. And organize the layers in the Layers panel so that the Burn Monuments layer is on top, as it is, followed by the Road Inventory, followed by the Census Tracts, followed by the Jurisdiction. And go ahead and save your QGIS document into the Lab folder as lab7.qgis. Okay, so let's take a look at the data. So let's right-click on Jurisdiction and go Zoom to Layer. So does it look like all the layers are lining up together? So open the layer properties for each layer and investigate their CRSs. So let's look at Jurisdiction. Oops, there we go. And so under General, you can see this is selected CRS. Here, so we have the 4326 Road Inventory. Bring it up here a second. Another selected CRS. And Burn, we're in a NAD 83 Harn 4152. So they're all in different coordinate systems. So let's make sure the on-the-fly projection is enabled, and it should be. There we go. So make sure that's selected. All right, so let's go ahead and make sure that we select NAD 83 Harn, New Mexico Central as the CRS for the map. And so let me scroll down. Let's just go for New Mexico. And let's see here. And I want New Mexico Central, NAD 83 Harn, feet US. All right, so the EPSG code is 2903. And I will click OK to set the project CRS. Okay, so projecting on the fly is fine for cartographic purposes. However, when conducting a geospatial analysis, the data layers involved should be in the same coordinate reference system. Typically, data layers will also be clipped to the extent of the study area to reduce rendering and data processing time. These procedures are often referred to as normalizing your data. For the typical analysis, a majority of your time is spent on obtaining data and normalizing it. Once all the data is organized and normalized, the analysis can proceed. So we will want to put all 4 layers in the same coordinate reference system for this analysis. And we're going to put them all into the state plane coordinate system. So right-click on the Burn layer in the Layers panel and choose Save As. This will open the Save Vector Layer As window. So click the Browse button. For the coordinate reference system selector. There we go, this one right here. And from the recently used coordinate systems, you should see this NAD 83 Harn, New Mexico Central feet coordinate reference system. If not, then you can type in 2903, which is the EPSG code, and you can select it there. So we're going to click OK with that selected. We're going to check Add Save File to Map. We're going to click Browse, and we're going to save that in our My Data folder, but we're going to do burn_SPCS and click Save. There we go. And I'm going to click OK. And so you can now see that we have a burn SPCS file in our map. So we no longer need the original burn layer, so I'm going to right click on it and I'm going to choose Remove. And when it asks me if I want to remove, I'm going to click OK. And now we're going to repeat the steps to save the census tracts into EPSG 2309. So you're going to right click, Save As, going to Browse, name it the same thing, but _SPCS. I'm going to choose EPSG 2309, click OK, I'm going to remove the original. All right. So let's go ahead and save our project. And for the map, we need a polygon that represents the county boundary. The census tracts collectively defines the county, so we'll use the dissolved spatial analysis technique to create a county boundary from the census tracts. So I will click Vector, Geoprocessing Tools, Dissolve. And when I click that, it opens up the Dissolve window. And for my input vector layer, I'm going to choose my census tracts. And I'm going to dissolve based off of attributes. So I'm going to, let's see here, dissolve all, since I want to dissolve them all. And make sure Add to Canvas is checked. And I'm going to click OK. Oop, I need to specify an output shapefile. Forgot to do that. So let's go to my lab folder. And I'm going to name this Bernalillo County.shape and click OK. Okay, so that is completed. So I'm going to click Close. And I'm going to remove the intermediate data set of the census tract since we don't need that anymore. And once again, just save my project. I always like to save my project. So we're going to want to filter the monuments, so we only have the ones with orders and classes that we're interested in. So we only want monuments to meet the following requirements. Elevation order is 1, last recovered on or after 1995. Satellite observations were used for monument coordinate determination. And so A, B, and C, so what I just said, so elevation order is stored in the attribute field elev order. Last recovered is stored in last RECV. And satellite observations is stored in sat use. So to do that, I'm going to double click on the Burn SPCS layer to open the layer properties. I'm going to click on the General tab. I'm going to find the feature subset area, which is called the Provider Feature Filter. And I'm going to click on the Query Builder button to bring up the Query Builder. And this is where we can write a SQL query to filter our data. So I'm going to double click on the field elevation order. So let's find that here. There we go. And I'm going to click the equal sign. I'm now going to click the All button under the values, and I'm going to double click on 1 so that it reads elev order equals 1. So since we want monuments that have both an elevation order of 1 and were last recovered on or after 1995, we'll now use the AND operator. The AND operator selects records that meet conditions on both sides. So I'm going to click on the AND button. And after the AND operator, I'm going to create the portion of the expression dealing with the last received. Sorry, not received, recovered. So we're going to do, let's see if we can find last recovered. There we go. And we're going to do greater than or equal to all, and I'm going to choose 1995. Let's see if they have that in here. Yeah, so we're going to do 1995. So I'm just going to type that in. Okay, and I'm going to do another AND. Actually, sorry, I shouldn't have done 1995. What I have to do is I have to grab the first the closest one to 1995. So this is 1994 one here. And then we're going to do AND. And I'm going to do sat use equals yes. And so I'm going to click the test button, and it should say that I returned 48 rows. Great. And I'm going to click OK. And that's going to set the query. And I'm going to click OK again. And now you'll see I have a lot less monuments. So let's go ahead and open up the attribute table just to make sure that we're getting what we want. And so you can see we have 48 features, which is what we wanted. So perfect. So let's close the attribute table and save our work.